First thing we are going to review is data collection. So there are basically 4 different types of samples we are looking at. 2 that are unbiased and 2 that are biased. So unbiased would mean that's a good representation of the data. So keyword we are looking at here in the simple random sample is that it is random. So for example, pulling out of a hat, a spinner, a number generator, etc. For the systematic random sample, the key word is it is systematic. There is a system in place. Every 10 minutes, every 15 minutes, or every 10th item, every 30 items, there's a system in place. These are accurate representations of the data. Biased samples are something that maybe we aren't really thinking clearly, or we're not taking the time to get an accurate representation of the population. Convenient sample, keyword, it's convenient, it's easy. We're not really accessing multiple different groups, and it's easy to collect. Voluntary response sample is something where you need to volunteer a response. Surveys are an example of that. Or if you think about like reviews for products, you don't have to write a review. And generally speaking, if you write a review, it's either a very good review or a very bad review. And it's not representative of all people using that product. So let's determine whether each sample is biased or unbiased and explain why by specifying what type of sample it would be. So a college psychology professor needs subjects for a research project to determine what colors her college students find restful. She selects 25 students using a random number generator. So I do see the word random, a random number table, okay? I do just want to make sure that who she is surveying would represent what she's looking for. So she's looking to determine colors that her college students find restful. And so she's selecting 25 college students that would be representative. So it is unbiased and it is random. So because it is a simple random sample. Number 2. To determine the percent of teenage girls with long hair, Teen Magazine published a mail-in questionnaire. I see something that is a questionnaire. It's mail-in. You don't have to fill out the questionnaire. You are volunteering to submit it back. So this is biased because it is a voluntary sample. Number 3. Stacy needs to test if the oranges in her orchard are sweet enough to make orange juice. She tests 1 out of every 20 oranges on the tree. There is a system in place. She's doing a certain item interval. So this is unbiased. That's an accurate representation. And because it is a systematic random sample. And last example, a company interested in opening a gym on its premises for all employees is interested in opening a gym on its premises for all employees. They ask all third shift workers, 11 p.m. to 7 a.m., if they would use the gym and what hours they would like the gym to be open. So they're asking third shift workers, and specifically they want to know what hours they want it open. Well, they aren't asking the first shift or the second shift. They're only choosing one shift because it's easy, it's convenient. And of course, those workers are going to want it open they don't care about the other hours. They only care when they're there. So that's not going to be an accurate representation. So this is biased towards the third shift. And it was convenient because we're just asking one group rather than trying to mix it up. So because it is a convenient sample. All right. Looking at the best measures of center and variation. And that should say for problems 5 and 6. So we are determining the best measure of center and variation. When we want the best measure of center for the best measure of center, we're looking between the mean and the median, okay? What I want you to remember is that the mean means there are no outliers. The median would be if there are outliers, okay? Because if there is an outlier and you use the mean, if it's way higher, it's going to bring the mean up. If it's way lower, it's going to bring the mean down. So in median, since we put it in order from least to greatest, those outliers get crossed off as we're crossing off to find the middle value. So looking in here, 20, 19, 18, 21, 25, 99, 17, 27, 23. I see that 99 is way bigger than the rest. That is an outlier. And outliers would tell me to use the median. So I can cross off that outlier as I'm finding the median value. And what matches up with median? We use the median to find the IQR. That interquartile range. Oops, sorry. I put that in the wrong spot. Because there are outliers. And then, as I said, when we use the median, we use that to find the IQR. And why? Because we used the median. Number 6, 58, 60, 54, 63, 50, 64, 59, 60. They are all relatively close to each other. I don't see something that's way higher or way less than the rest. So if there's no outliers, I'm using the mean. And my reasoning, because there are no outliers. And then what matches with the mean? Not the IQR, because the IQR goes with the median. The mean goes with the MAD, the mean absolute deviation. It has the word mean in it. And why do we use the MAD? Because the mean is the best measure of center. And then last part, we're going to look at a data set and find all of the measures of center: mean, median, mode, Q1, Q3, IQR, range, and MAD. So first thing that I am going to do is I am going to calculate the mean. So I'm just going to write down here a little lower. Calculating the mean. So let's add this up. I have got 15 plus 17 plus 21 plus 24 plus 13 plus 17 plus 30 plus 32 plus 13 plus 33 plus 20 plus 17. I get 252. I'm going to do this twice just to double check and make sure I didn't make a mistake. 15, 17, 21, 24, 13, 17, 30, 32, 13, 33, 20, and 17. I got the same answer. We divide this by the number of values: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. And we get a mean of 252 divided by 12 is 21. So for my mean, it is 21. The reason I double checked is because if this mean is wrong, all the work that I'm going to do to find the MAD would be wrong. Now I'm going to find the median by putting this in order from least to greatest. So starting with 13, another 13, 15, 17, 17, 17, 20, 21, 24, 30, 32, 33. Let me make sure I've got 12 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, it is in order from least to greatest. Now let's find the median. So I'm crossing off lowest, highest, lowest, highest, lowest, highest, lowest, highest. Remember, if you cross off a lowest, you have to cross off a highest. Lowest, highest. If I crossed off 17, I'd have to cross off 20, and there's nothing left. So these are both in the middle. So to find the median, we're going to find the average of these two. 17 plus 20 divided by 2 is 18.5 for our median. And then our mode, which one occurs the most often? Well, it's easy to see now that we're in order from least to greatest. 17. Even though 13 repeats twice, 17 repeats 3 times, so that is our mode. Now, we're going to find our Q1. So to do that, we need to split it in half. So right in between those two median values. And now we're going to find the median of the lower half. So we're crossing off lowest, highest. That 17 is included. Lowest, highest. If I crossed off 15, I'd have to cross off 17, right? Cross off, and we'd have nothing left. So both of these two are in the middle. I'm going to add these two together and divide by 2 to find the average, which is 16. And that makes sense. That's right in between 15 and 17. So our Q1 is 16. Now we're going to do the same thing to the top half. Crossing off, 20 is our lowest. Lowest, highest, lowest, highest. We are left with 2 values in the middle, so we're going to find the average of those 2. And when I divide those, I get 27. So our Q2 is 27. Sorry, Q3 is 27. Our Q2 is our median, which was 18.5. Our IQR, we are going to do our Q3, which is 27, minus our Q1 of 16, and that gives me an IQR of 11. Our range, we're going to take our highest score of 33 minus our lowest score of 13, which gives me a range of 20. And then last but not least, we have our MAD, which might drive you mad. So we're going to find the difference between each value and the mean. So our mean was 21. So we're going to subtract each number from 21. And remember, distances are always positive. So 21 minus 13 is 8. I'm going to write it down here. So we have 8 plus another 13, so 8 again. 21 minus 15 is 6. 21 minus 17, and maybe you can do these in your head, is 4, plus another 4, plus another 4, because there's 3 17s. 21 minus 20 is 1. 21 minus 21 is 0. They're the same number. 21 minus 24. Remember, if you're doing it on the calculator and you get a negative, you ignore it because distance is always positive. So that is 3. 21 minus 30 is 9. 21 minus 32 is 11. 21 minus 33 is 12. Now that we have all of these distances, we're going to find the mean of that. So we're going to add these all up. 8 plus 8 plus 6 plus 4 plus 4 plus 4 plus 1 plus 0 plus 3 plus 9 plus 11 plus 12 equals 70 divided by, there were 12 values. When I divide that, I get 5.83, which I'm going to round that to the nearest tenth. That's just about 5.8. And that is it.